Hello and welcome to Forbest Academy, and welcome back to our AMC 10-12 preparation videos. This week we have been breaking down past paper questions from the AMC 12, and we've been looking at the concepts involved and how to use them to answer the questions. Today's question we're going to be looking at logarithms, and we've been given the sequence log base 12 162, log base 12 of x, log base 12 of y, log base 12 of z, and log base 12 of 1250 is an arithmetic progression. What is the value of x? So an arithmetic progression is a progression where we have a common difference. We either add or subtract the same amount to each term. We can represent that with the first term being a, our second term being a plus d, our third term being a plus 2d, our fourth term being a plus 3d, and our fifth term being a plus 4d. This will continue until our progression comes to an end. So in this instance here, we have been given our last term of the progression is our fifth term. Log base 12 is 1250. So we know that our first term, a, is equal to log base 12 of 162, and our fifth term is equal to log base 12 rather, log base 12 of 1250. So we know that a is equal to log base 12 of 162. So for this second equation we have here, a plus 4d equals log base 12, 1250. We can actually write that as log base 12, 1250. Rather than writing it as equal to a plus 4d, we know that a is log base 12, 162. So log base 12, 162 plus 4d. Okay, let's see if we can work this to find a value for 4d. So if we subtract log 12 of 162 from both sides, we're going to get log base 12, 1250 minus log base 12, 162 is equal to 4d. Now we should remember from our previous logarithm videos, if I have one logarithm subtract another logarithm with the same base, we can write it as a single logarithm with the two terms being divided. So log base 12 of 1250 over 162 is equal to 4d. Now we can simplify that division there slightly. If we divide, we simplify it as a fraction slightly, we can get that as 81 on the bottom, and the top, if I divide that by 2, I'm going to get 625. I'm also going to divide both sides by 4, so I can have a quarter. Log base 12, 625 over 81 is equal to d. Now, if I have a logarithm with a coefficient of any coefficient, what I can do is I can raise that logarithm, or the values inside the logarithm, to that power. So I can write this as d is equal to log base 12 of 625 over 81 all to the power of 1/4. Now the power of the quarter is the same as looking at the fourth root. The fourth root of 625 is equal to 5. And the fourth root of 81 is 3. So we've got d is equal to log base 12, 5 over 3. So we've been asked what our value for x is. So now we have a value for d. We can work out what that value of x is. Now we remember from the beginning, x is our second term in our arithmetic sequence. So that must be equal to a plus d. So log 12 of x is equal to our first term, which was log 12 of 162, plus our common difference, which is log base 12, 5 over 3. Now, as we discussed before, when I have two log of the same base, this time added together, we can combine them as one logarithm, multiplying those two values together. So log base 12 of 152 multiplied by 5 over 3. And that's going to give me a value of log base 12. I'm going to do 162 times by 5 over 3, which gives me 270, which is our answer of B. Thank you very much for watching this video. Please like and subscribe our channel. And if there are any past paper questions you would like me to break down on this channel, please leave a comment below and I will create a video for that question. Thanks very much for watching. I look forward to seeing you again soon.